entire equation to the function d dx. So here's the function d dx. I'm going to feed the entire equation into it. Okay. And then by the rules of d dx, and this is a function, right? It follows a rule. And one of the rules is that it plays well with the pluses and minuses of a function. And what that means is that I can take, instead of feeding the entire thing to d dx, I can feed each one of these terms into d dx as follows. So I take d dx of y cubed, and I can add that to d dx of x cubed plus d dx of y plus d dx of x. And that's equal to d dx of 7. Okay? So you feed the whole equation into d dx, and then because d dx plays nicely with addition signs and equal signs, I can break it up into each one of these pieces. Okay? So rather than have to eat this whole thing, let's just focus on one thing at a time. What is the derivative of y cubed with respect to x?
3y dy dx. 3y squared.
3y squared, and then whenever you're taking the derivative of something that's not x, you tack on dy dx. Okay? So it's 3y squared dy dx. What's the derivative of x cubed?
3x squared.
3x squared. And if you want, you can write dx dx. But of course, the derivative of x with respect to x is 1. So you don't have to write it. You can. If it helps you remember, always tack on dy dx or dx dx. What's the derivative of y?
1.
1. 1 times dy dx. Derivative of x. 1 dx dx. Derivative of 7. 0. Okay? So now what's up next? We wanted to find dy dx, and we have an equation with a bunch of dy dx's in there. How do we solve for dy dx? I'm going to rewrite this equation up here. 3y squared dy dx plus 3x squared times 1 plus 1 dy dx plus 1 is 0. Okay? How do I get dy dx by itself?
Subtract 3x squared and 1 to the other side.
Yeah, I'm gonna move the terms that don't have dy dx over to the other side by subtracting. So this is going to give me 3y squared dy dx plus dy dx equals negative 3x squared minus 1. And now what?
Factor out dy dx.
I'm going to factor. So it becomes 3y squared plus 1 times dy dx equals negative 3x squared minus 1. So you see what I did? If you take this and multiply by dy dx, you're going to get 3y squared dy dx plus dy dx. Factoring that out. And now finally, to get this over to the other side, because I'm multiplying by dy dx here, I need to divide by this 3y squared plus 1. Okay? So my final answer is going to be dy dx equals negative 3x squared minus 1 all over 3y squared plus 1. Okay? so as a recap, feed the whole equation into dy dx, but then again, you can just do each term by itself, if that's easier for you to digest. And you gotta remember that if you're taking the derivative of y, you need to tack on dy dx. If you're taking the derivative of an x, you just write the derivative, 3x squared. Okay? So now I want you to try number 2 and number 3 on your own or with a partner for the next 3 or 4 minutes. 0. Okay? Take the derivative, that's rule number 1. Set it equal to 0. And what does the derivative tell you? It tells you slope at a point, right? So what you're doing is you're figuring out when is the slope 0. Okay? So if I give you a function like y equals x cubed minus 12x, and it's any problem in chapter 12, or in chapter 3, what should you do? Take the derivative. What's the derivative? X squared minus 12, and what do you do next?
Correct.
You set the derivative equal to 0. Then what?
Critical numbers.
Solve for x. So take derivatives equal to 0 and then solve for x. If you can remember that, you're going to be able to do like 95% of the problems in this chapter. So when is the slope 0? The slope is 0 when 3x squared minus 12 equals 0, which is when 3x squared equals 12, which is when x squared equals 4, which is when x is equal to plus or minus 2. Okay? Now, rule number 2. Draw a number line. And on that number line, put down the points where it's equal to 0, where the derivative is equal to 0. Okay? Then take a deep breath and pick a point here, here, and here. Any point you want, doesn't matter. I'm going to pick 0. I'm going to pick -3. And I'm going to pick 3. Okay? So wherever the derivative was equal to 0, we'll call those the critical numbers because they're critically important. You draw your number line and you pick numbers between critical numbers. That's rule number 2. What do you do with these numbers that you pick?
You plug them into the derivative.
You plug them into the derivative. Kind of small. You plug them into dy dx. Okay? So let's do that. dy dx of -3, well, dy dx is 3x squared minus 12. This must be 3 times -3 squared minus 12. -3 squared is 9, so this is 3 times 9 minus 12, which is 27 minus 12, which is 15. Okay, what you need to do is ask yourself, is 15 positive or is it negative? Positive. So over here, write a plus sign and circle it. Now, plug in 0. Three times 0 squared minus 12 is 12.
It's negative.
Negative. Put a minus sign there above 0 and circle it. Okay, finally. dy dx positive 3 is 3 times 3 squared minus 12, which is 20, which is 15. Is 15 positive or negative?
Positive.
What do I do?
Put a plus sign and circle it.
Put a plus sign and circle it. Okay. So, what we've just found out from rule 1, rule 2, is that rule 1 told us that above negative 2, my graph looks like a flat line somewhere. And I'm going to say below positive 2, my graph looks like a flat line. Over here, the slope is positive, so it must look something like that. At 0, it was negative, so my graph must look something like that. And then over here at 3, it was positive again, so it looks something like this. Okay? You have a fairly decent idea of what this graph looks like? Yeah. This is the graph y equals 3x squared minus 12x. Okay? Now where, if I was an ant walking along this path, okay, where would I feel like I'm at a maximum? Like I'm about to go off a roller coaster or something.
-2 and your min's a 2.
Negative 2, I have a relative what?
Max.
Relative max. Positive 2 is a relative
Yeah.
min. Okay? That's all we're doing in these two sections. Take the derivative, set it equal to 0. Draw a number line, pick points in between the critical points, and figure out whether the function's increasing or decreasing. You can stop it on my